In this example, we will determine the Thevenin equivalent circuit at nodes A and B. And the first thing we'll do is determine the Thevenin voltage, which happens to be the open circuit voltage between nodes A and B. Now looking at this circuit, it has a 15 amp current source, and that 15 amps is split between two paths. One is 20 ohm path, and the other path has half the resistance. It's 5 plus 5, or 10 amps. And if we do the math, we will find that the current through the 20 ohm path is half of the current through the 10 ohm path, or 5 and 10 amps respectively. You'll notice that both paths, the voltage drop is 100 volts. It's 20 times 5, or 10 times 10. So the open circuit voltage is the 10 amps going through the 5 ohms, and that's the Thevenin voltage, which is 50 volts. Alternatively, since the voltage drop across both 5 ohm resistors is 100 volts, okay, then by voltage division, the voltage drop across terminals A and B is 5 ohms over the total resistance of that path, which is 10, times the total voltage drop, 100, or again 50 volts. Now, there are several ways to get the Thevenin resistance. And since there are no dependent sources in our circuit, one way to find the Thevenin resistance is to simply turn off that independent source and then find the resistance between terminals A and B. So in the circuit that I just brought up, you'll see that I've turned off or killed that current source so that I is equal to 0 in that branch, which basically means that current source is replaced with an open circuit. And then we'll find the resistance looking into terminals A and B. That is the Thevenin resistance. And again, we'll see we'll have two paths between A and B. We have a path that goes through a 20 plus 5, or 25 ohm path, and then the other is 5 ohm. So our Thevenin is 5 in parallel with 25, which equals 5 times 25 over 5 plus 25, which is 30, which is equal to 125 over 30, or our Thevenin is equal to 4.167 ohms. Now, if we want to draw what the Thevenin equivalent circuit looks like, it is just one voltage source in series with one resistor. So final answer, if we draw it, would look something like this. Voltage source of 50 volts, a resistor having a value of 4.17 ohms if I go to 3 significant digits, and there's our terminals A and B. And that is the final answer.